Hello there, welcome to the October 2020 paper. Here we're looking at question 10. Use the factor theorem to show that g of x is divisible by 5. So if we're using the factor theorem, we have to plug in f of 5 into our function. And if it is 0, then by the factor theorem, g of x is divisible by x minus 5. So let's put it in. It's going to be 2 times 5 cubed plus 5 squared minus 41 lots of 5 minus 70. So let's work this all out. Let's do it individually and really clearly show it, because we do get 2 marks for it. So 5 cubed is 125, times it by 2 you get 250, plus 25 minus 205 minus 70. And this bit here is going to clearly add together to make 275. This bit here is going to clearly add together to make minus 275, which will cancel to make 0. Let's just write our conclusion now. As f of 5 equals 0, by the factor theorem, x minus 5 is a factor. Oh, I was meant to put g. G is supposed to be there. Is a factor of g of x. Moving on to part B now, hence showing all your working, write g of x as the product of 3 linear factors. So it's going to be 2x cubed plus x squared minus 41x minus 70. This is going to be equal to 3 linear factors. Let's write it as x minus 5 times some quadratic first. Let's expand the bracket, so it's going to be x times something to give us 2x cubed. That would be 2x squared. But when I expand the bracket with the minus 5 now, I'm going to get minus 10x squared. So I'm now going to need to add 11x squared to get me up to my x squared. So I'll need to put plus 11x here, so that I'll multiply out to get my 11x squared. But when I put my 11x here, I also get minus 55x. Now, how do I get from minus 55x to minus 41x? I'm going to have to go up by 14. So I'm going to have to add 14x to make it minus 41x. So it's going to have to be add 14 here, and that will also multiply out to make the minus 70. Perfect. Let's now factorize that quadratic. So it's going to be x minus 5, 2x, and x. So it's probably going to be 7 and 7 here and plus 2 here. That will give me 7x and 4x. So there we are. That's the answer for this question here. 3 linear factors. The finite region R is bounded by the curve with the equation y equals g of x, the x-axis, and the line below the x-axis. Using integration, find the exact area of R. So first of all, what I'm going to do is I'm going to just sketch out what I've got here. In fact, let's do it on the next page. So we've got g of x equals x minus 5, 2x plus 7, and x plus 2. So let's visualize what this graph is going to look like then. It's going to have so it's going to have x-intercepts at 5, minus 2, and minus 7 over 2. It's a positive cubic graph, so it's going to look like that expression there. So let's just read the question again. Find the region R that is bounded by the curve with y equals g of x, the x-axis, and lies below the x-axis. So it's going to be this area here. This is the region R that we want to work out. This point here was minus 2, and this point here was 5. This point here was minus 7 over 2. So it's going to be the integral of 5 to minus 2 of 2x cubed plus x squared minus 41x minus 70 dx. So let's do that integration. It's going to be increase the power by 1, divide by the new power, plus increase the power by 1, divide by the new power, minus increase the power by 1, divide by the new power, and with it 70, it's just going to be 70x, between 5 to minus 2. Let's go ahead now and simplify and substitute in 5 into what we've got here. So the first one, if we just put 5 into the whole thing, it's going to be half times 5 to the power of 4, and then plus 1/3 times 5 to the power of 3, and then it's going to be minus 41 over 2 times 5 to the power of 2 minus 70 times 5, and that's going to give us minus 1525 over 3, and then minus the number minus 2 going in, and that's going to be minus 190 over 3. So now let's add or maybe subtract these two. 1525 over 3, whoops, and then minus 190 over 3, and that's going to give us minus 1715 over 3. So find the exact value of the area, so therefore the area of R is equal to 171 over 3. And there we are, that's the answer for this question here. So 10 marks in total for that question there, for question 10. Let's now move on to question 11.